Okay, we begin by taking the derivative of both sides of the equation x squared plus 2y squared equals 8x. I think we pretty much did this in a preceding video, but let's just go ahead and do it again with a little more perspective. Okay, so that's going to be the derivative. Of course, we're taking the derivative with respect to x. The derivative with respect to x of x squared plus the derivative with respect to x of 2y squared plus the derivative with respect to x of our 8x. Now, the derivative with respect to x of x squared is 2x. Derivative with respect to x of 8x is just 8, and that should be very easy to understand by this point. Now, the derivative with respect to x of 2y squared is what? Well, the derivative with respect to y of 2y squared is 4y. However, the derivative is with respect to x, so the derivative with respect to x of 2y squared is the derivative with respect to y times the derivative of y with respect to x. In other words, 4y times dy dx. Now, we've worked out and seen where that dy dx comes from in a number of different ways. They all lead to the same conclusion. If you have here a function of y and you do the derivative with respect to x, then y is going to be a function of x, and the chain rule is going to dictate that you're going to have a dy dx. Okay, then the rest of the process is simple enough. We subtract 2x from both sides and divide by 4y, and we get dy dx. So we have the derivative of y with respect to x equals 8 minus 2x over 4y. Now we have another equation, and it's a little longer. It's no more difficult or complicated in any significant way, but there are a few more steps. So let's see what we do with this equation. Okay, our equation is y cubed minus 2x squared y squared. I'm trying to button the shirt here. Okay, again, y cubed minus 2x squared y squared. I'm not going to read them. Well, yeah, 4xy plus x squared minus 3x plus 5 equals 0. Just the equation in the document. Okay, so we're going to take the derivative of this with respect to x. Then we're going to take the derivative of every term with respect to x. We're going to take the derivative with respect to x of y cubed, then of 2x squared y squared, then of the 4xy, then of the x squared, then of the 3x, and then of 5. We have a derivative to take on every one of those. So those derivatives are very straightforward. The derivative of x squared is just 2x. The derivative of 3x is just 3, and that's negative, so we have 2x minus 3, and the derivative of 5 is 0, so we don't even have to write that down. Now, the other terms all involve y expressions, sometimes in combination with an x expression, sometimes not. Okay, first we have the derivative of y cubed with respect to x. Now that's the derivative of y cubed with respect to y multiplied by dy dx. The derivative of y cubed with respect to y is 3y squared. Then, well, we have to use a product rule here. We're going to have, we'll factor out the 2, and then we have the derivative with respect to x of x squared times y squared, first function, derivative of the first times the second, plus x squared times the derivative with respect to x of y squared, first function times the derivative of the second. That's just our product rule. And for the derivative of 4xy, again, we factor out the 4, and then we take the derivative of xy. And that's going to be the derivative of x multiplied by y. It didn't look all that much like a multiplication sign. That kind of looked like an x. So let's make sure that's clear. So it's derivative with respect to x times y, derivative of x with respect to x times y, okay, and then x times the derivative with respect to x of y. Well, simplifying that, first term is already simplified. The derivative of x squared is 2x, so we have 2x times y squared, inside the parentheses, of course. And then we have x squared times the derivative with respect to x of y squared. That's the derivative with respect to y of y squared, which is 2y, times the derivative of y with respect to x by the chain rule. And of course that's multiplied by our x squared. Okay, might have already said that. Derivative with respect to x of x is just 1, and that's multiplied by y, so we just get y. And then x times the derivative with respect to x of y, well, derivative with respect to x of y is just dy dx. So we have x dy dx. Okay, now it maybe looks a little intimidating, but it's really quite simple. All our dy's, dy dx's are just going to be plain old dy dx's. So to solve for dy dx, we just separate the terms that have dy dx in front of them, we separate the terms that include dy dx as a factor from the terms that don't. And we put the dy dx terms on one side and the other terms on the other side. So before we can do that, of course, we got to distribute through a couple of expressions, and that's very simple. I'm not going to read that to you. You can check and make sure that -2 distributes through here, giving you these two terms, and 4 distributes through here, giving you these two terms. So what do we have? We have a dy dx term here, a dy dx term here, and a dy dx term here. We're going to leave those on the left-hand side of the equation. And we're going to factor them out. So our 3y squared dy dx is represented by the 3y squared here, which is, of course, multiplied by the dy dx according to the chain rule. And then a minus 4x squared y, which is multiplied by dy dx, and a 4x, which will be multiplied by the dy dx. I've already done the factoring, of course, but you can verify that that's correct. And then the other terms will be on the other side with opposite signs. Okay, in other words, we're going to add this, we're going to add this, we're going to subtract this, and that's what we're going to have. Now, I had to move over this way. I was out of board space, but all we have to do to get dy dx then is divide through by this. And we have the numerator, which is just everything that was on this side, the denominator, which is the factor in front of the dy dx. So, very simple process once you get used to it. Not difficult. You're never going to have a square of a dy dx. It's always going to be linear. This equation will always be linear in dy dx, meaning you're always going to be able to factor a bunch of stuff out with the dy dx, everything else on the right-hand side, then you always divide by whatever you factored out, and you get your final expression. One other note, I kind of missed what I had up here, and I had a big old smudge down the board here. You can see that if you back up a little bit. So I kind of repaired that. Okay, again, looking at the derivative of y to the 1/2 with respect to x. Okay, you could break that down in the other paradigm for the chain rule as the y to the 1/2 function would be f of u equals u to the 1/2, where u equals y of x, and then the derivative would be y prime of x times f prime of y of x. Now, f prime is just the 1/2 u to the -1/2 function, and if you do f prime of y of x, you will have substituted y of x for u, so you're going to get the 1/2 u to the -1/2, except that u is now y of x. So you're going to have 1/2 y of x to the -1/2 multiplied by y prime of x. And that then can be written as 1/2 y to the -1/2, that's what we have here, and then times y prime. And of course I've left the parentheses x out of these two functions. They are understood implicitly. So, just another way of writing this derivative, so that the derivative of y to the 1/2 with respect to x is the derivative of y to the 1/2 with respect to y, dy dx is 1/2 y to the -1/2 y prime. Just another way of looking at it. So we have several ways to look at the emergence of this y prime or dy dx, meaning the same thing, of course.